or 4 different things occurring at the same time. So today is just kind of like the intro to it, and then we'll build as we look for the rest of the week. So the first thing, what's probability? Julia?
The chance of something happening.
Yeah, the chance of something happening. There are 2 different types of probability we'll talk about today. One is called theoretical probability. The other one is called experimental probability. The theoretical probability is like the mathematical statement of probability. So that's what's supposed to happen based off of the math. Experimental probability we'll talk about as well. That actually is like you do an experiment, you perform a survey, and you have actual data. But theoretical probability is what happens in theory. This is the math behind it. So numerically, like mathematically, this is what's supposed to happen based off of the numbers. So when they tell us the probability of it raining today, of course that's always in theory, and they always seem to be wrong. It's supposed to be really sunny today. It just isn't sunny yet. At some point it's going to get sunny today. So when we find probability, it says when all outcomes are equally likely. So there's a same chance of it happening for whatever event we're talking about. The probability that event A can occur, we use P for probability, and then whatever we're finding we place inside the parentheses. So the probability of this event occurring can be found by the number of outcomes in event A over the total number of outcomes. And then there's a little Venn diagram right next to it, a little bit of reminder of geometry. So the outside bubble includes all of the outcomes, and if I count all of them, in this little example there are 7 dots. The number that are in A are 3. So the probability of event A occurring in my little Venn diagram would be 3 out of the total of 7. So you count everything that's in the big bubble, and then the number that would be in what we're looking for. It says a theoretical probability is often just called the probability of the event. We don't really say the theoretical probability of this happening. It's just going to say the probability that it happens. So the first set of examples are pretty straightforward. We often do probability with cards and dice. They're 2 things that we can quickly find the probability of. So it says you're rolling a standard 6-sided die. So there are 6 sides. It's a standard die, meaning one side isn't heavier than the other. It's just a regular old die that you have laying around at your house in one of the games. Find the probability of rolling a 5. So our goal is to find the probability of rolling a 5 on one die. So on the bottom goes the total number of outcomes. On the top would be the number that are 5. Holly, how many outcomes would be on a dice or a die? Yeah. How many numbers are 5 on a die, Holly? Oh, 1. So the probability of rolling a 5 is 1/6. So 6 options, 1 out of 6. So then the next one, the probability of rolling an even number. Well, 3 of them are even. 3 of them are odd, out of the 6 on my die. So that would really just be a half. Half or even, half or odd. And then letter C says in a standard deck of 52 cards. So again, standard deck of cards means you don't have any jokers. How many suits do you have in a deck of cards? Ollie? 4. So we have 4 suits. So we have the heart, we have the diamond, we have the club, and the spade. Those are my 4 options. pretty good drawings. Not so bad today. We want to find the probability of getting a red queen. So a queen is considered a face card. We have the jack, the queen, the king. This would be our face cards, and then the ace. How many queens are in a deck of cards? How many red queens are in a deck of cards? Odette? 2. Yeah. So the probability of getting a red queen would be 2 out of 52. So 2 of them are red, 2 of them are black. Half the cards are red, the other half are black. So our diamonds and hearts are the red ones, the spades and the clubs are the black cards. And Odette, 2 out of 52 will reduce to 126. So you have a 1 in 26 chance of getting a red question. That's just basic probability. So the questions at the bottom are a little more interesting because it uses permutations and combinations. Makes you think a little bit harder because we're going to try and pull in the permutation combination part and then also think about finding probability. A community center hosts a talent show for local musicians. On a given evening, 7 musicians are scheduled to perform. The order in which they perform is randomly drawn. It says, what's the probability that the musicians perform in alphabetical order by their last name? Assume that no 2 musicians have the same last name. So the first thing, is this going to be a permutation or combination? Let's just decide that first. Julie. Permutation because?
Like the order matter?
Yeah, so this is talking about alphabetical order. So we're first going to determine the total number of ways that these musicians can occur. Because they're going to occur in a special order when they perform. So how could I figure out just the total number of ways? So let's just talk about the total number of ways first. So how many ways could these musicians perform? Julian?
You would do 7P7.
Yeah, so I have 7 musicians. 7 of them are performing. All of them are performing on a given night. And Julian, that number would be
5,040.
5,040. Our goal is to find the probability that they would perform in alphabetical order. So we know the total number of ways they can perform is 5,040. That's that number that we found. So doing 7P7 gets us all the different ways that they can perform. The 7 people. How many times would it be in alphabetical order?
Only one.
Only once. It's only going to happen once that they're in alphabetical order by their last name. It's not going to happen in more than one time. So the probability would be 1 out of 5,040 that they would perform in alphabetical order. So we calculated the total number of ways, and then thinking about how many times it would be in alphabetical order, it's just going to be once. The second question is a little different. It says, you are friends with 4 of the musicians. So you know 4 of them. What's the probability that the first 2 performers are your friends? So we have 2 performers now that we're thinking about instead of all 7. And now instead of them performing, we're just saying, well, you're friends with these people. What's the chances of you being friends with 2 people from the group? So we still have to think of 2 different things. So we've got to think of the total. There we go. So we still need to think of the total number of ways that we can choose 2 musicians. And then we need to think of the ways that we could have friends. A little line there. So let's start with the ones that are your friends. How many different combinations could you have for them being your friends. So how many friends are there that you know in your group? How many are we saying that they're performing? Emma, how many friends do you have in this group? 4. So we have 4 friends. It's a combination because we're just saying, hey, what's the probability that the first 2 are performing? Not in order, just that the first 2. So there are 2 of them. So 4 of them are my friends. I would figure out the probability that 2 of the performers, or the first 2 performers are my friends. So I have 4 that are my friends, the first 2. On the bottom, we have to figure out the total number of ways that we can choose 2 musicians. They might not be my friends, but we're just looking at 2 of them because we're thinking about the order that they would occur. Sorry. So there are 7 total musicians, and we're looking at 2 for the first 2 spaces that would be performing. So the first one is the number of friends that we have, the 2 people that we're looking at for the first and second. The bottom is the total number that are performing, and again, we're choosing 2 musicians. So we're not choosing all of them, we're just looking at 2. This is a combination because the order isn't important. I'm ordering them in first, second, third, fourth, fifth, sixth. So we would have 4 factorial, 4 minus 2, and 2 factorial. And then on the bottom with the 7. So Odette, do you have a number for the top? Oh, nope, sorry. Anybody have a number for the top? Holly, what do you have for the top? 6, and then on the bottom, 21. So there are 21 different ways that I could pick 2 out of 7 people. There's 6 different ways that those 2 out of the 4 would be friends. And then Holly, what would that reduce to? 2 sevens. Questions? So those are a little trickier, so you're gonna have to think like, how does the combination work? What number would have to go on the bottom, that big total, out of what we're looking for on the top? So we're just applying the combination into the probability. So on the next page, it talks a little bit about odds, and odds you'll see a lot in betting. I'm sure the odds on the game last night, there was some kind of odds on the basketball game last night. Does anybody know how odds are different than probability? Connor? Yeah, so, well, it could be not happening. So odds, you usually compare the event, so the chance of it being happening or the chance of it not happening, but you're comparing the 2 options instead of comparing it out of the total. So odds doesn't use the total number. Instead, odds uses the chance of it happening versus the chance of it not happening. So we'd say odds in favor or odds against. So there are 2 different ways that you can look at odds. So when all outcomes are equally likely, the odds in favor of an event A and the odds against an event A. So the first one says the odds in favor. So that means the top number is the number of outcomes in A, whatever we're looking for. On the bottom, it's going to be the number of outcomes not in A. So now you're comparing for versus against instead of out of the total. So probability is out of the total. Odds is what you're looking for versus what you're not looking for. The other way is just flipping it around. When it's odds against, then the number not in A is on top. And the number of outcomes in A is on the bottom. So you'll never have the total in odds. Actually, both pieces combine to make the total, but the total number would never be on the bottom. It says the odds in favor or against can be written in the form of a fraction or written in the form of a ratio. And I would say you're most likely going to see it written as a ratio when you're seeing like the odds given for the Super Bowl, the odds given for the basketball game last night, the odds given for the Stanley Cup. It's going to be written as a ratio. So we're going to write them as a ratio. We're going to keep probability as a fraction. So underneath, finding odds, a marble is drawn from a bag where we have 6 red, 12 yellow, 9 black marbles. Find the odds in favor of drawing a red marble. So we want to look at the ones that are red versus the ones that are not red. That's how you would do odds in favor. So Matt, how many marbles are red? 6. How many marbles are not red? 21. And that would reduce to 1 then. So the odds in favor of drawing a red marble would be 2 to 7. I had 2 chances of getting a red, 7 chances of not getting a red marble. Looking at the odds against drawing a black marble. So now we have the odds against. So that means you're flipping it. So the odds of not getting a black marble versus the odds of getting a black marble. So Rebecca, how many of them are not black marbles?
15.
And how many of them are black marbles?
It's 18 and 9.
18 and 9? So 18 are not black marbles and 9 are black marbles. And then what would that reduce to?
2.
Yeah, 2 to 1. So I have a 2 to 1 chance of not getting a black marble. Double the chance of not getting a black marble. Questions with the odds. So for versus against. If I add those together, my total should be 27 in both those cases. So when you add the initial comparison together, that's still your total number that you have. Questions? So the other type of probability, so we have the theoretical probability, we've got odds, and then the last one is an experimental probability. And this happens when you literally perform an experiment, you give a survey. But the key thing is that you have actual data. So instead of saying I have 6 sides on the die, this is what should happen with the 6 sides on the die. We have actual data to use and to calculate. So we have actual numerical values to look at to find the probability. So when the probability, the experimental probability is performed, it consists of a number of trials. So I might roll a die 200 times. And then I can count the number of times it lands on a 1, 2, 3, 4, 5, 6. And now I have data to use to kind of find probability. So the probability of event A, it's pretty much the same, but it's the number of trials instead of the number of outcomes. So not a hashtag, but a number sign. The number of trials for A versus the total number of trials. So it's the same thing as experimental probability, except you're looking at how many times did something happen. How many times did the event occur? So if you flip over, you'll see a little chart. So when you perform a survey or you kind of take data, one way to organize it would be in a chart. It says here that exam grades of students in history class are shown in this bar graph. Find the probability that a randomly chosen student in this history class received a C or better. So this is actual data that is taken from a history class. So it's not just the theory that it might occur, because in theory, if we have a 70%, usually we would say 70% is in the middle. You would hope that, 75% of your students would at least get a 75 or at least a C or better. But we want to actually see what happened in this class. So how would we figure out the probability of a student getting a C or better? What would you do? Julia?
You would add first the numbers of the students that got a C or better, and then divide that by the total number.
Yeah. So he said, look for the ones that have a C or better, which in my bar graph, looking at those three values, the students that got a C or better. Julian, how many students got a C or better?
27.
27. That's a 7. And then on the bottom will be the total number of students that were in the class. So Julian, the total number in the class would be
31.
31. Does that reduce at all?
No.
No. So 27, 31. So 27 students have a C or better out of the 31 students in class. So that's actual data that you're using. Instead of just saying, in theory, this is what should happen if I have a deck of cards or if I have a die that I'm rolling. So looking underneath, let's see here. Let's look at 1 and 3, and then I want to make sure we do the little bullseye problem down below. So using a deck of cards, find the probability of getting a black ace, and then go down to number 3 and look at the marble. And see if you can find the probability of drawing a marble. Actually, that says find the odds in favor of drawing a marble. So the first question is just regular probability. So that's considered theoretical probability when we have a standard deck of 52 cards. It's not giving us a chart with information, it's just saying we have a deck of 52 cards. Number 3 is asking you to find the odds in favor of a bag of marbles. So Abby, what would the probability of getting a black ace be? How many black aces are in a deck of cards? 2 out of the total? And then you said 1 over 26. Looking down at number 3, we have a bag of marbles that have 6 blue. Yellow, 9 white, and 11 green. Find the odds in favor of drawing a yellow marble. So, Melanie, how many yellow marbles are in our bag?
6.
How many are not yellow marbles?
6.
What would that reduce to? Divided by 2. 3, 2. Yeah, there. So that's the odds in favor because you have for versus against. So the ones that are yellow versus the ones that are not yellow. Questions? So the last little diagram on there would be a little more interesting. You throw a dart at the square board shown. Mine is in color. Unfortunately, they don't copy in color. Your dart is equally likely to hit any point inside the board. So we're not counting the darts that hit the wall on the outside. Are you more likely to get 10 points or 0 points? So the 0 points would be anything outside of the circle. The 10 points would be inside that bullseye area. Now we want to know, do you have a better chance of getting 10 points or do you have a better chance of getting 0 points? How would you figure that out? Julian?
You would need to find the area of the 0 points and the area of the 10 points. And divide that.
Yeah, so we need the area of the 0 points, we need the area of the 10 points, and we also need the area of the whole thing. So we need the total amount of area. So let's start with the area of the whole thing. A little bit of geometry here. Let's find the area of the big square. That's the big board, the whole board. So Julian, the area of a square is length times width. And since it's a square, the length would be 18. The width is 18. What is 18 squared? Holly? Right, 324. Looks like that's inches. So the whole board is 324 inches. So we need to figure out the area of the bullseye, the smallest circle. Because that's one value we're going to compare. And then we have to figure out how to get the area of the black part, the outside part. How do you find the area of a circle? Maddie, how do you find the area of a circle? Circle. You were giving me triangle.
Yeah, I'm just trying to go back to the
Area of a circle.
the radius of
Yeah. Pi r
square.
squared, yeah. So the area of a circle is pi r squared. In this case, what's the radius of the yellow circle right here? What is that radius? Julian? 3, yeah. So the radius of the inside circle, each one of those is 3. So the inside circle has a radius of 3. So we're looking at pi times 9. Give me 2 decimal places. What is 9 times pi? Mikey? 28.27. Alright, so now we know at least we can look at the smallest circle inside. What else are you going to have to find? If I want the kind of compare the area of getting 0 points, what else do you have to find? Julian?
You need the area of the big circle.
Yeah, we need the area of the biggest circle as well. This is a lot of stuff to find. So we have the area of the whole square, we have the area of the small circle. We need to get the area of the biggest circle, which is going all the way out. So 3, 6, 9, adding those 3 together. We're looking at 81 pi. Because each one of those bands has a radius of 3. Julian, what is 81 pi?
254.46. I mean 47.
All right, so now we have to do one last thing. Because our goal is to get the area of 0 points. How do you find the area of the 0 point black region, Julian?
You subtract that area of the large circle from that whole square.
Yeah, so we need the whole square, which is that nice 324, and then the area of the whole circle. And then we can finally find the probability. Odette, do you have that number? 69.53. So we want the probability of getting 10 points, which is a bullseye, versus the probability of getting no points. The total number would be the whole square, so that 324 goes on the bottom of both of these. On the top, the 10 points was the smallest circle, so that 28.27. On the top of the 0 points would be the 69.53. You can kind of see just by looking at those two numbers, but actually calculate that probability. Divide those two numbers, don't leave it as a fraction inside of or a decimal inside of a fraction.